Okay. Hello, everyone. Welcome to this Gala webinar. We're gonna wait less than a minute. Let's just give people a chance to log in and take their seats. Alex, in the meantime, would you like to switch on your webcam so that people can say hi? Yeah, there you go. Yep. Okay. So Alex,
hi, everyone.
is our presenter today and he's ready to go. So let's just wait a little bit until everybody's logged in. We have a big crowd today. Okay. All right, let's get started. So once again, hello everyone and welcome to today's Gala webinar. I am Isabella Massardo, Gala's content strategist, and today's presentation is focused on AI-enabled linguistic quality assessment. I think I said it correctly, for quality estimation. And you see the speaker already, Alex Janiszewski. He is Director of AI Deployments for Localize. Now, before we get started, as usual, a few housekeeping items. You can use the chat button on your control panel to chat with other attendees. At any time during the webinar, you can submit your questions to the presenter. Just type your questions into the QA at the bottom of the control panel, and as time allows, Alex will address as many questions as he can during the QA session, which will be, as always, at the end of the presentation. This webinar will be recorded, and I'll share the link with you in a follow-up email after the event. And in any case, you'll find the recording also on the Gala website, either tomorrow or on Monday at the latest. So let's not waste any time. Alex, the floor is yours.
Hi, everyone. Very nice to meet you virtually. Good morning, good afternoon, good evening. So another household thing to mention, housekeeping thing, is that there are a couple of polls. So on these polls, I'm going to stop sharing. Isabella will share her screen to do the polls. I'll prompt her. So just please be aware of that, and then it will come back to me for sharing. So the presentation is called Smart and Smarter, AI-enabled smart LQA. The reason I called it that, it's a bit of a play on this movie that's 30 years old called Dumb and Dumber with Jim Carrey, right? And kind of the idea that I was playing off of is that now with all of these different innovations that we have in natural language processing and machine learning algorithms and ultimately AI, we can really build now tools and methodologies based on these tools that we have, on these algorithms, that would allow us to look at linguistic quality in a smarter way. So hopefully you'll see that from my presentation. So that's the name. That's the reason for the name. So as Isabella mentioned, quick explanation about me. I'm Alex Janiszewski. I'm Director of AI Deployments at Localize. I've been in the industry for over 20 years in various guises, starting from linguist. My native language is Russian, in addition to English. I also worked as a globalization strategist, program manager, etc. Before we localized, I worked at ProMT, which is a machine translation provider. And really the last 10, 12 years, I've been focusing on machine translation, estimating quality for machine translation, helping build programs and deployments with machine translation. And the last couple of years particularly, I've transitioned into AI, of which machine translation is a part of. So we have our first poll coming up right now. So let me stop sharing, and Isabella, if you can share.
Here we go. I'm going to read the question because those who will see the recording won't be able to see the poll. So the question is, how frequently do you use source content profiling in production workflows? And let's wait. People are voting. Takes more or less a minute. Okay, almost there. Okay. All right, I'm gonna close it at the count of 3. 1, 2, and 3. Okay. So here are the results. If you want to comment, Alex.
Yeah, perfect. So it looks like it's almost split half-half, right? In the sense that never and rarely represent about 54%. And by the same token, the other 47% are people who sometimes or always use it. So at least we're beginning to see a trend that this is something that is important. Right. So hopefully for the people who are not using it, I'll show you some reasons why it may be worthwhile to do so. For the people that are using it sometimes, hopefully this will be occasion to use it a bit more. And for the people that are always using it, my kudos to you. And I hope this may give you some additional parameters that may be of interest. So let me go back then to my presentation now. Okay, so I'm going to talk about this smart LQA methodology, and I've broken it up into 4 sections. First, I want to define what it is, right? Secondly, after we define what it is, we'll talk about when is it used, at what point in the global content lifecycle. Then I want to explain to you, and this is going to be kind of the meat of the presentation, how is it that it's used? What sort of insights we can get from this, both on the source and target. And by the way, I'm kind of already letting the cat out of the bag, because the second poll, and as much as I asked you about the source, we're going to have a similar poll on the target, because the idea is that this can be used both for the source and target. And after we talk about kind of the current state, how it's used right now, I want to talk about the future and kind of how, at least from our side, we envision that it can be used and what's next. And hopefully, this will be a nice invitation for a discussion, because I'm sure with so many people here, those people who are using it may have some ideas as well, how this methodology can be used. Okay, so what exactly is this smart LQA, right? The idea is that it's a methodology that helps us to inform global content business decisions, but using AI, right? So rather than kind of putting our finger to the wind, for example, or looking just at historical experience, again, now we have machine learning algorithms that give us the underpinnings to really make data-driven decisions. Now, what's nice about this is that we're looking at the whole gamut here. When we're saying global content business decisions, we're not only talking about source, we're talking about everything. So we're talking about the suitability of the source in the first place before it goes off and becomes a localization project. We're talking about predicting content that's at risk. We're talking about doing our LQA on the target side in a smart or targeted sort of way. Again, rather than just saying, hey, I'm going to randomly take the beginning of the file or the end of the file, we can look for particular sentences that are problematic. And then other things that are very useful, these are both hot topics: machine translation, quality estimation. How do we correlate what we see in the source and in the target that we've translated to what the quality estimation is telling us? Are there things that are in conflict, or are they in concert with each other? The same thing with post-editing distance, right? Whether you use sheer Levenstein, whether you use something like character, whatever the algorithm is, again, it's nice to be able to correlate this both to the source and to the target. So again, as far as what is it and what do we do with the source, right? So a lot of times, at least in our case, we find that the source can be problematic for at least 3 main reasons. Number one, the content could be written by authors that are non-native speakers of the language. It could be created by technical specialists for a non-technical audience, right? So basically, you have someone who is a developer who would be much happier developing, but has to write error messages, and those error messages can be cryptic, right? And lastly, it could be content that was okay previously, but has a certain shelf life. It's dated, and it really doesn't adhere to the current brand tone or voice, right? So the idea here is we can analyze this content to see if it needs to be rewritten before it goes off into translation into 10, 15 or more languages, right? So just an experience from for me, when I started my career as a linguist, I was working for a CAD/CAM company, and I had to translate this wonderful phrase in English, degenerate geometry, right? And I looked at it and I said, okay, I know what degenerate is. I know what geometry means, right? When I put them together, I have no idea what this means whatsoever. So I did, I was fortunate enough. I was an in-house linguist. I found the culprit, right? I went to the developer. The developer also happened to be Russian like myself. And I said, explain to me, I don't care, either in English or in Russian, however you feel comfortable. What does this mean, right? What followed then was a 15-minute conversation, right? That was at a graduate student level, because the guy was a physicist and mathematician. I'm a linguist, so we completely didn't understand each other. So when I said, okay, but can you boil down to me what you're trying to say? And he said, well, what I'm basically saying is that the system cannot perform a calculation. The data is invalid, therefore we can't perform a calculation, right? At which point I said, couldn't you have just written that instead of the cryptic degenerate geometry, which is so esoteric that only a few people in the world like yourself can understand it, right? So I'm giving this explanation because part of the idea here is to catch such patterns to prevent these sort of source queries, right? And imagine the luxury that I had, because I could just go and speak to the developer. But if you imagine this multiplied by 20 languages where you don't have the developer and lots of people are involved, it's horribly inefficient, right? So if we can catch this ahead of time, it reduces this inefficiency. And that's part of what this source suitability and smart LQA is supposed to address. So that's only one side of it, right? The other side of it is the target. Okay, wonderful. We have the source. Off it goes to localization. Now we've localized it or post-edited it in a bunch of different languages. Well, before it goes off to LQA, before it goes off to a corrector, proofreader, et cetera, we can evaluate the target too. Does this target deviate from the previous style, right? And if so, we could throw a warning. Does this target introduce unnecessary complexity that's not present in the initial source? And again, I'm not saying that there's an answer here, because maybe that complexity could be warranted if you're doing transcreation. But maybe if it's a different type of content that's more straightforward, we could track that complexity, and it is unnecessary, right? And that allows us to determine whether this data needs to go through LQA for additional data-driven checks and corrections. Now, the last point is, when we talk about LQA, the reason we call it targeted or smart is because it focuses on problematic files and segments within them, right? So the idea is, rather than saying, let's take 5% of the file, okay, where? At the beginning, at the end, in the middle? Why these 5%? Why not 7%? Why not 10%? Right? You can see how this argument can become crazy. Ideally, what we're trying to accomplish here is to say, here is the highest probability that this file is problematic. And in fact, here are the segments in it that are problematic. And I'll be showing you some of these markers along the way. And lastly, this data can be used to retrain the engines. I mean, I put dynamically in parentheses because not all MT providers have this ability, but technologically, the ability does exist. Okay, so when exactly is this used, right? How does this fit into the content lifecycle? Now, again, I'll be the first person to admit that this is a very simplified content lifecycle. I understand that people can have lots of different steps. With different translation steps, different editing steps, subject matter review, et cetera. Things can go back and forth, DTP. I've really simplified it for the purposes of our conversation, right? So essentially, we have a source. We can evaluate the suitability of that source. Then we have a target. We can evaluate the suitability of that target. We do LQA, and then we do MT retraining, and then the cycle starts over again. Now, the two points, the two dots that are in orange, is where the smart LQA methodology comes in, right? So the idea is, you have your source, we evaluate the source suitability. That's our first fork in the road. We can see if particular files fail and push those back to the technical writers and say, please rewrite them until they meet our threshold, right? That's one possibility. The other possibility, and probably more likely probability, is that clients will say, listen, we need to get this to market. This needs to go. Even if there are flaws, it needs to go to localization. But what's nice is we can say, great, it's going to go to localization in 15, 20 languages, but we can already predict what's at risk, right? We know where the problems are in the source, And we can already tell our translators, our editors, our PMs, our LQA team what to look out for, right? What content is at risk. And I'll show you later how we do that, right? Then we have a target. That target, again, has been now post-edited. And we can, again, check the suitability of that target. You know, I was mentioning things like similarity versus dissimilarity, unnecessary complexity, right? And then the same thing can happen with LQA, and then the project is delivered. So that's kind of the idea, that it can be used both on the source and target side. So the more interesting thing is, okay, how is it used? So the first thing we do here is we configure thresholds, right? And these thresholds are based on an average for that domain plus standard deviations, right? The idea of standard deviations is that this captures the outliers. And what's important to point out is that this is a relative measure, right? This is not a one size fits all, right? Because there are going to be different thresholds and different patterns for different products and for different domains, right? So I'll show you that in a moment, how that works. So when we're talking about standard deviation, those of you who are mathematicians or have quite a lot of experience in statistics, you already know this, but just to kind of level set, I'll try to explain this in a relatively straightforward way. So hopefully most people like animals, or cats or dogs, right? So let's say we have 5 dogs and we want to see what is a big dog and what is a little dog, right? So we have 5 dogs and we measure their height according to their shoulder, right? And then the green line represents the average. You can see that it's a little bit under 400. Right? Now, that in and of itself doesn't tell us whether a particular dog is large or small, right? This is just the average of 5 dogs. So what we need then is standard deviation, right? And that's basically, that's these blue markers here, right? So this is what tells us that these 2 dogs, the one in gray and the one in white and black here, right? They're a little bit above the average, but they're still within the standard deviation. Right? So there's a standard deviation on the upper end and standard deviation on the lower end, right? And what this basically is telling us, that the Rottweiler is in fact a large dog because it's outside of the deviation. And by the same token, a Dachshund is a small dog because it's on the lower end of the deviation, right? So the idea that I'm trying to capture here is it's all relative. Right? So that's why all of this needs to be calibrated, configured for each specific domain and threshold, right? So let's put this practice into real life, right? So here are some of the features that I have here with different content types, right? Now, let's just focus on average word count, right? This is the average word count for the file. Imagine I had an absolute value and I said, okay, any sentence that is 25 words or more is considered a long sentence, and I'm going to call the file a fail based on that. Well, in that case, anything here that's legal would be a fail, and anything that's repair instructions would be a pass, right? This wouldn't help me in any way, right? What I need to acknowledge is that if I'm dealing with end user license agreements, if I'm dealing with legal writing, just by its definition, it's going to be much longer. So I need to calibrate the word count, not just 25 and longer, where all of this would fail, but what's the standard deviation, at least 1, possibly even 2 standard deviations out for this content, right? And then 67 would be very likely a fail, whereas 45, 46, 48 would be a pass and perfectly fine. Right? The same thing can be applied here for repair instructions, right? If I had more data points, I might say that 9 words is okay, but 11 words per average is a fail, right? And the idea here is, so this is the idea of calibrating for a different domain and different product. And this sort of calibration happens not only for one feature, but a bunch of different features. And I'll be talking about these features in the upcoming slides, but I just wanted to kind of explain the concept to you. So now we get to the point of salient features. So what is it that we're identifying? What are the markers for us of passes, failures, or reviews, right? So some of the things that we're looking at are parts of speech, right? We're looking at adjectives, nouns, proper nouns, numbers, right? We're looking at adjective noun density, right? Meaning that I have a noun phrase that consists of 2 or even more, typically 3 or 4 nouns in a row, right? Why is that problematic? Because if you're dealing with, I mean, it's already difficult for a machine to figure out if I have 4 nouns in a row, what belongs to what and how they relate, right? It's also difficult for human beings, and particularly so in languages that have a case system, right? If you have German, if you have, let's say, Slavic languages, right, where you have a case system, the marker for the end of the word will tell you what role it has in the sentence. So figuring out what belongs to what, whether this is the genitive case or the accusative or dative case, it's rather difficult with a noun phrase. So we want to have that as a marker. Certainly, long words are problematic, right? And long words aggregated, so complex words basically means words that are polysyllabic, 2 syllables or more, right? Because that generally could mean that the word is gone beyond its initial root. It could be a gerund, right? And typically long and complex words point to long sentences, right? And long sentences are going to be problematic, certainly for a machine, and highly probable for a human being too. By the same token, we want to look at short sentences because short sentences of 1 or 2 words can be ambiguous, right? We're looking also at stylistic similarity or dissimilarity, right? Meaning that you wrote a certain way, now you're not writing that way anymore. Is that good or bad? We don't know. We're telling you that it is, and maybe you've made a concerted effort to change your style now. Also, we're looking at readability and complexity metrics. Is this sentence and ultimately this file very difficult from the standpoint of semantics, right? And lastly, we look for correlations to p distance, as I mentioned, and empty quality estimation, so we could see all of this together. Now, one thing I want to point out, right, just so that there's no misunderstanding, this is not spell checking, right? This is not like using Hunspell. This is not using regular expressions, for example, that would say it's always obligatory that you have a space before the exclamation mark in French, right? This is not using something like Xbench that will tell you inconsistencies between source and target. We're less interested in that because that already exists. It's a well-trodden path, right? And it's working quite well. This is really more infused with AI, right? Infused based on NLP frameworks. You'll see that a bit later when I talk about under the hood, that gives us the probability that something based on these features is a more or less complicated sentence. Okay, so where do we dig, right? We have all of these features, that's all fine and good, but how do we know which features really are the most salient, right? So this is the idea of a heat map and looking at correlations, right? These are basically Pearson correlations. I'm running them in a heat map using Python. If you like, you could do the same thing in Excel. But the idea is you look at 2 features on a scale from -1 to +1, and that will tell you how strongly correlated they are. So for example, if it's warm outside, I'm going to wear a t-shirt, right? A short sleeve shirt. And the 2 things will go up together. The warmer it is outside, the more frequently I'll wear a short sleeve shirt, right? So that's a strong positive correlation. A strong negative correlation is the opposite. The hotter it is outside, right, the less likely I am to go skiing, right? Because I'm not going to go skiing when the sun is shining, right? And that's a strong negative correlation. The hotter it is, the less I'll go skiing. Now, the reason, and these are expressed as +1 and -1. The reason this is important is because this shows us where to dig, where to look for problems, what features affect other features. So here you'll see that there's a very, very strong correlation between word count and long word count, 0.86, right? So it basically says that when we have a long sentence, that sentence tends to be composed of long words. There's also a very strong correlation between complex words, words that are polysyllabic, and long words, right? That kind of makes sense, right? If a word is long, chances are overwhelmingly that it will be a complex, a polysyllabic word, right? And lastly, we have a strong negative correlation, relatively strong, at -0.41 between reading ease and complex words, right? So here what we're saying is when our complex words go up, our reading ease goes down. The sentence becomes less readable, right? So if I wanted to look at a particular sentence and where to fix things, again, whether I'm doing it on the source side or on the target side, these sorts of correlations help me quite a bit. So last chart, again, just to kind of show you again, this is, again, on a very granular level where to dig. If, let's say, we look at adjectives here, right, what this is telling me is I have a file. This is the number of sentences on the vertical axis, and this is the number of occurrences. So I have 0 adjectives in about 200 sentences. By the same token, I have 3 adjectives in about 25 sentences, right? So again, what this is telling me is if one of my markers are adjectives, right, this is where I should be looking at those sentences that have 3 adjectives. You've got other parts of speech here like determiners, pronouns, proper nouns, adverbs, etc. So you could do similar things. So let's talk a bit more about what we do with source suitability. Right here again, I show a chart. One of the things that we could look at is sentence similarity. Right. So let's say I have a bunch of sentences. If they're very, very similar to each other, right, that shows me on the one hand that I'm kind of being consistent with my style. Right. The other possibility is that maybe I'm not, again, depending on the content that I have, if I'm doing transcreation, this is probably not a very good sign, right? I'm not being diverse enough in my representation, in my sentences to really capture the readers, right? If this was transcreation meant for a trade show or a conference, this is not very good because I have lots of similarity. On the other hand, if I'm writing technical documentation and I want something to be very, very tight, almost to the point of controlled English, this is actually quite good, right? So some possible remedies, right? We can not run the project until it's improved. We can route the project to a different workflow altogether, right? Maybe this needs to go to transcreation. Maybe it needs to go to human translation because we see that it would be very problematic for machine translation. Maybe based on the topic, we need to send this to a different MT engine altogether, right? Maybe we have MT engines for different domains. We find that, lo and behold, this is not technical documentation. It's really marketing, and it needs to go to a marketing MT engine. And I mentioned this before, if we actually go forward with the project, we alert of a higher LQA risk to everyone involved in production, everyone down the line who will be consuming this source that may have flaws in it. Another way that this is used is, and I kind of alluded to this, is for source query analysis, right? This is an actual example from a client, right? So what we did is we analyzed 600 segments for potential do not translates and 600 segments where there was ambiguity for source and meaning, right? This basically meant that translators were coming back and saying, is this term do not translate or is it not, right? I don't understand the source. What exactly are you trying to say? Or this is ambiguous, please rephrase, right? And so we identified thresholds for each category, ran these thresholds and identified 400 potential queries. So some of the things that you'll see marked here is, do we see 5 or more nouns in a sentence? This particular sentence is very telling. It has 27 nouns, right? You can see the word count here, 41 words. This reading ease, the lower this number is, the less readable it is. The high is 121. The low can actually go into like negative, like 300, 400. This is a very low number, right? You could see lots of long words, lots of, in this one, you have lots of proper nouns, right? So the idea is we could ahead of time catch these potential queries. And the way we figured this out, and this is a very, very safe, very conservative estimation. Imagine I'm a linguist. I need to translate this wonderful sentence with 27 nouns. I come back to the project manager and say, what does this mean? Please find out from the client, right? The project manager says, I don't know. Let me write to the client. They write to the client. The client might say, I don't know. Let me ask my subject matter expert, right? Then this whole round trip comes back to me again. By this time, very easily, everyone involved spent 15 minutes on this one query, right? Just for one language. So if you imagine that you have 400 queries at 15 minutes a query, you're spending 101 hours between both the client side, the vendor side. If you say just very conservatively, you're spending $60 an hour, if not more, right? Depending on who's involved, this is the sort of savings that we're talking, right? And this is just for 400 queries. Now, the client actually came back and told us that one query like that, because of the number of languages involved, actually becomes a multiplier of 27, right? Because it's not just one linguist in one language, it's a bunch of different linguists who are saying, I don't get it, please tell me what it is, right? So if you can catch this ahead of time, you would make very significant headway as far as saving time and as far as saving cost, right? Based on these thresholds and these features that you set out. So actually, let me stop sharing here. And Isabella, if you could do the other poll, please.
Yes, just a second. All right, let's go to the second poll. And here we go. Okay, so the question is, how frequently do you use target content profiling and or MT quality estimation in production workflows? Please vote, let us know. Okay, almost there. Okay, I'm gonna close at 3. 1, 2, and 3. Okay, and here are the results. If you want to comment, Alex.
Okay, so this one actually is even less. So it seems like roughly 2/3 of people do not use it. 1/3 of people do use it. Yeah, and I asked this question, like honestly, I was actually expecting, to be honest, a bit of the opposite. I thought that because there are more MT quality estimation tools like post-edit distance that are already baked in into some TMSs, that people might be using them. And then there's actually a large effort being made to put in quality estimation too, in addition to like post-editing metrics into TMS tools. So hopefully this number will go up in the future as well, just because these tools exist, and hopefully the sort of methodology that we're talking about will help underscore that as well. All right, let me share, and I'll go back then to my presentation. Right, so let's talk a bit about the target now, right? How is it used on the target side, right? So the possible remedies are, you could go back to the linguist for more editing because they didn't do enough editing, or perhaps this is too complex and they need to make it less complex. We could alert the LQA team that's going to come after the linguist that there's a higher risk. We talked about the fact that this information can be used to retrain the MT engine. Other things, you could map this to the client LQA methodology, right, and set a threshold based on that to hopefully reduce the amount of failures once it ultimately gets to the client side. I mean, I spoke about, and hopefully you'll see this, that you know, this allows you to, this methodology helps you to reduce LQA dollars and really spend them where they ought to be spent in a targeted fashion. And you can confirm. Right now, we actually do have in a lot of TMSs, especially if you work online, you can get productivity metrics, you could get P distance. For some of them, you could get quality estimation. What's nice is all of these data points can be correlated to what you see in the target suitability. And you could see to what degree this is working or not. Right here, I gave a screenshot. This is an example just of the sort of plotting you could do. So here, you can see that this particular sentence is an outlier, right? You can see the vast majority of the sentences lie in this 3D space, right? And here, the features we're looking at are numbers of noun in a sentence, numbers of verbs in a sentence, and how many characters, right? So this is an outlier, and part of the reason it is because it has 8 nouns, right? That's the z-axis over here, and it has 66 characters, right? As opposed to these sentences, which tend to be much, much shorter. It's just a nice way to kind of to visualize where your problems are. And what's nice is this actually tells you what the sentence is, so you could hone in on that immediately. So we're kind of getting to the end of how it's used. So this is the summary view, right? What I'm going to do is in the next few slides, I'm going to show you a summary view, and I'm going to show you a file view, and then I'll ultimately show you a sentence view. And I'm going to kind of work from top to bottom. the idea is that there are different people obviously involved in the localization process, and they may have different needs, right? There may be some people who just care about just a summary view. Tell me what passed, what failed, what needs review, right? Then there are other people who are going to be actually fixing this, right? Either the technical writers or the linguists who need to have the information, tell me what file and what segment I go into, right? So the idea how this is aggregated, I'm showing this a little bit here, is you basically have a bunch of different features, and each of these features will get a true or false, right, for the features. And then the segment will be called a fail, a review, or pass, depending on the number of these features, right? So let's say I have 9 features, and again, these are highly configurable, right? So let's say I have 9 features and 4 of the features fail, I make 4 or more fail, I may call the segment a fail. If let's say 2 or 3 fail, I may say review, and if 1 fail, I may call it a pass, right? And that ultimately gives you this pie chart here that says, okay, so I have 10 files, 5 passed, right? 1 merits review, and here are, and 4 failed, right? So basically this tells you how many features failed. It gives you this pass, fail, review per segment, and then you aggregate it up to a file level, right? So if you have 100 segments, and let's say in a file and 51 of them failed, you can say, okay, this whole file is a fail. But what's nice is you can still go in at the segment level and only focus in on the ones that failed and ignore the ones that passed, right? So that's one summary view. Another summary view that actually, this is nice because this shows you passes and fails per domain and per locale pair, right? So here, for example, I could hone in on this and say, okay, so for example, for my domain service, I have out of 82 files, 14 of them failed, right? And then I can begin to look at individual languages and see whether, let's say, my knowledge base, if I ran it, failed more, or if my service failed, and in what languages, right? So here, for example, for Russian, you could see I have a 10% failure, right? I ran 10 files, 1 failed, right? But let's say service in Spanish, I've got 2 files that failed, 20% out of 10. Right. So what's nice here is that you can see this aggregated on a domain level and on a locale level. Right. So now you could focus in here. You would, the conclusion you'd likely draw is, hey, my English is not that great. Maybe I ought to fix my English. And here, of course, a lot of times translators are left to mop up the flaws and inaccuracies in English. Right. And you could see that, maybe I ought to focus on Italian and Spanish because I have a few more fails here than, let's say, I have in other languages. Right. So here, this is the idea of garbage in, garbage out, right? How do we prove this? I mean, we know, right, that if you have poor source, it's going to significantly increase the probability of poor target. Right. What's nice is we can actually prove this objectively, right? If we're talking to a technical writer, we can say, look, we can show you what sort of problems you can cause for 15, 20 languages by tracing source to target correlations. Like we can really prove to you that, garbage in does equal garbage out, right? So how do we do this, right? Here we've got 7 files in English. We've got 7 files in German. They're exactly the same file, right? So basically we took these English files, we translated them into German. And we're looking at salient characteristics, right? So now we kind of are beginning to really get into the weeds, right? So we're looking at things like adjective count. Lots of adjectives can lead to complexity. Lots of nouns can lead to complexity. Proper nouns, right? This could get into the question of, do I translate? Do I not translate? Word count, right? Obviously, the longer the sentences are, the more problematic they are. I spoke about long words, right? Words that are 9 characters or more, complex words, words that are polysyllabic. Nominalizations are a word not as its native part of speech, right? So a gerund, for example, right? Swim is the verb, swimming is the gerund, right? Those words, not in its native, not in its initial part of speech, can be problematic for machine translation engines, can cause confusion for human beings. LM score is a score of language models based on language models of stylistic similarity or dissimilarity. The higher this number is, the worse, right? It means that you're dissimilar. And lastly, flesh reading ease is basically if you consider how, for example, books are rated for different readers, right? You have some books that are rated for kids in pre-kindergarten, some books that are graded for first grade to third grade, fourth to sixth grade, college level, high school, right? Beyond college level, right? So the idea is that this flesh reading ease can tell us that the lower this number is, the more complicated something is, right? So typically in English, if you want to write for a grade school level of 6th or 7th grade, this number should be 60 or higher, and the highest is 121, right? And this number actually could get into the negatives. So here what we're doing is I've marked in yellow to make it a little bit easier. Of these 7 files in English, what file has the highest number in each category, right? Here, it's the opposite. It's the lowest number, because lowest number means complexity. So what's interesting here is that this particular file that ends in 9.6, of the 9 features, it's problematic for 7 of them, right? So this file would fail in English, right? We would say this has too many problems. This file needs to go back to the technical writer. But let's say for the sake of argument, we need to process this file. Off it goes to localization. Now we run the same experiment for German. Now, the only difference is in German, this flesh reading ease was developed for English. For non-English, it typically licks and ricks are used. And it's a similar formula that penalizes long words and that penalizes long sentences, right? And here, the higher this number is, the more complex it is. So what's really interesting here is that, again, I've marked in yellow the file that has the greatest number, that has the greatest number of problems. And lo and behold, you find a very tidy correlation. Here's this problematic file with 7 of 9 features that are poor in English. And lo and behold, of the 8 features, of the 9 features we have in German, this file displays 6 of them, right? So this really shows you that a very poor source certainly contributes to a very poor target, right? So you could see these correlations. Now, let's look at the sentence level, right? Yeah, so let's look at the sentence level. Before the sentence level, let's look at this particular file, right? I kind of showed you some features that were problematic. So what exactly is problematic? If you remember, I started out with that heat map, that correlation of where to dig, right? If you look at this on the vertical axis, this shows you the number of sentences, and this shows you the number of nouns in each sentence, right? So the way to read this is 3 sentences have 1 noun. Conversely, 1 sentence has a staggering 22 nouns. Yeah, I'm not making this up, 22 nouns, right? So if we say for our threshold, 6 nouns in a sentence or above is a measure of complexity, right? You can see visually looking at this that if you go from 6 to 22, this represents more than half of our sentences, if not 2/3 of our sentences. We could do the same thing with long words or more. Let's say we say a sentence that has 8 long words or more is considered complex, right? You can see that almost half the file, right? We go from here to here, almost half the file has complex words. And typically, now what the correlation tells us is that these two run together. So when you begin to look at this on a sentence level, by virtue of fixing this, you'll probably fix this as well and bring down the complexity of everything. Right? So this is kind of one, I'm just showing you examples of how you can think about this and how you could hone in on particular problems. So we were talking about the file, but let's take a look now at the sentence level, right? So let's look at a sentence level. I'm going to give you a few seconds to read this particular sentence in English. And as you're reading it, try to put yourself first in the mind frame of a linguist who needs to translate this into another language. And then when you're done doing that, also try to put yourself in the mind frame of a machine translation engine that needs to make sense of out of all of this, right? Now, I purposely took a very, very extreme sentence, right? This is the sentence that that I was showing you in the graph on the previous page, right? So if we take a look at the sentence, and we get the statistics for it. We have 42 words in the sentence, 22 nouns, 19 long words, meaning again, words 9 characters or more, and 9 complex words, meaning polysyllabic words, right? So, and this gives you a list of all of the nouns that are in here, right? So the idea is that a lot of these features, they correlate with each other. And if you're going to fix this or don't write this way in the first place, that'll take care of these things as well, right? Again, we're being descriptive here, right? We're not being prescriptive and saying you must do this as much as saying, we want you to know that this exists. If you want to reduce your likelihood of failure, you should try to take care of this. Just a quick slide on how it's used under the hood for people who are more technically interested in this, right? There are some NLP frameworks that are that we're running under the hood. We're running some language models for for similarity, dissimilarity. We're running tokenization, part of speech tagging. I alluded to some readability features that we're running, like Flesch Kincaid, complex words, long words, nominalization. There are some other secret sauces, if you will, but this is certainly some of the things that we're running. Again, I want to point out that this is not just pure machine, right? There's very much, it's of the utmost importance to have human input, because the machine can just tell you what these features are, right? They can say to what degree they correlate, but a human being really needs to go in and say to what degree it's correct that they are correlated. Right. So that's what allows us to do the fine tuning, to do the data analysis and calibrate and review these features. So what's the long-term vision? Ideally, this mixture of the two, in addition with post-edited distance and quality estimation, will allow us to create a predictive model. Again, I put the caveat if sufficient data is available, but ideally what would be nice to do is, very similar to if you've ever used something like Zillow, right? Where you go in and say, I live in this neighborhood, right? Here's how many bedrooms I have. Here's how many bathrooms I have. And it'll tell you how much your apartment or house is worth, right? Similar idea, if we put in all of this data, can it tell us ahead of time what is the likelihood of failure, right? Or passing. So these are just some numbers from us that we used, and we actually found, fairly significant time saved in LQA, fairly significant dramatic increase in pass rate and spend as well. Reduction of spend, I should say. So again, what's next? Continue to do human validation. We absolutely need human beings to tell us whether these features are salient or not. Maybe other features are more salient for a particular content type. I talked about the fact that, one of the things would be nice to begin building machine learning algorithms, using machine learning algorithms to build predictive models. This is actually a comment that I put in verbatim, taking from one of our German linguists. And when I showed her that file for English and German that was problematic, and I said, do you think that this would be helpful to you? I kind of highlighted in bold one of the things that she said was that this methodology has lots of potential and it gives very interesting insights. So let me stop here for any questions that you may have.
Okay, thank you, Alex. So first of all, I see a question from Anna. She says if you could go back to the slide on improvements, because it was only up very quickly and she couldn't. So maybe if you could share.
Yes.
And maybe
let's see.
Briefly.
Yeah, let me. Do you mean this slide of what's next, or do you mean this slide under the hood?
Let's see, Anna, maybe if Anna could write it in the chat, because I'm not sure. Let's wait for it. Okay, in between the improvement percentages.
Okay, yes.
Thank you, Anna.
Okay, yeah, so let me talk through it a bit more. So these are pilots that we ran, right? So what we found is when we're saying LQA time saved, right, we're basically talking about before that we were doing less targeted LQA, right? It was kind of based on this, a bit more, I would say, somewhat random methodology, right? Whereas now we could say, look, if you're going to, if we're going to measure the time and tell you, if you would have done this file the traditional way of taking 5% of the sentences, and now we're telling you, but take only these sentences in the file, how much time would that reduce for you, right? And that's how we got to that figure. I mean, aggregated over a bunch of files, right? So if you would have taken 5% of the file, right, and let's say if that file was 1,000 sentences, and you would say, okay, I would have read 50 sentences, right? And now we're saying, but our smart LQA methodology tells you, you don't need to read 50, you need to read only 30, right? That difference is that LQA time saved. The LQA pass rate improvement, it's basically, right, if we have major and minor errors, right, that are marked as pass or fails, presumably what this is doing is you're not even sending this to LQA in the first place until you've met certain thresholds, right? And if the linguist meets those more stringent thresholds, it reduces the failure rate, or to say it another way, increases the pass rate, right? So that's how that was measured. And then the LQA spend is basically a factor of this LQA time, right? In the sense that if we attach a dollar amount, right? Here's a person working on this, here is their salary and their loaded benefits, right? Insurance, retirement plan, et cetera, right? And now they're working, X% less, how much does that represent? So I hope I answered your question.
Thank you, Alex. So we have a couple of other questions. First of all, Milena, she's asking, how do you decide how to customize the threshold? Are the threshold always predefined? Do they work for every language or for every type of text?
No. So that's what I was trying to get at with that calibrating thresholds. I would liken it very similar to the idea of training machine translation engines, right? So we kind of have a sense, using whatever metrics, be it blue, be it other metrics, what's good and what's bad, right? So we have a sense of, historically, right, we know in this process what's just absolutely bad, right? So if we're talking about, if we don't have enough data and we start out with something generic, we could say, look, these features are bad, right? When you have 5 or more nouns in a sentence, that's bad. When you have a sentence that's more than 25 words, that's bad, right? Again, for particular domains. When the ideal thing is to have enough data from a client to actually calibrate it, right? So then we could go ahead and run a statistically significant number of files and begin to see like a bell curve, right? We begin to see outliers, a couple of standard deviations out on the low end, on the high end, and we could say, these are, if we want to be very stringent, maybe go out 2 standard deviations. If we want to be more liberal and have less fails, go out only 1 standard deviation, right? That's what would help us calibrate those thresholds. The important thing that I was trying to get at with that slide is the thresholds are configurable by product, by domain, by client, et cetera. And it's really important to get enough data so you can calibrate it. I hope that makes sense.
I think so. A question from Georg is referring to garbage in, garbage out. And he says, we cannot reasonably expect that the count of salient features varies between source and target. Do you agree?
So it's true that, okay, short answer, yes, it's true. long answer, yes. It's a bit of a problem because, unfortunately, a lot of these readability metrics, they were built for English first. So there are lots more of them for English, right? As we get into non-English languages, there are less and less of them, right? So for example, now what's nice is this part of speech, though, that's something, and word count, like these features, we can get that for like all languages. Things like nominalization, it's a bit more difficult to get for some non-English languages. German just happens to have it, right? So yes, it's true that English has more features, by the same token, I think you can begin to see some greater correlations, right? Like what we have seen, in fact, is when particular files fail in English, overwhelmingly those same files happen to fail, or at least I would say cause pause, if we want to be tactful about it, in non-English languages.
Okay, thank you. Two questions from Pavel. The first one, how valuable are the readability features in the LQA analysis in general?
I would say it depends on the domain. I think they're less valuable for legal writing, which by its inherent nature is going to be more convoluted. I think it tends to be more helpful for technical writing, which is supposed, for technical content like user documentation, which ideally is supposed to be more tight. I think really where they become more valuable is this gray area where you have marketing masquerading as technical content, right? That gray area where you begin to write something that's maybe meant outside of technical documentation, but it's still called technical documentation, would go to that workflow, would have that price point. But in reality, now you're beginning to see something that's less readable, and you could kind of prove and say, listen, but this is causing more cognitive load to the linguist.
Okay, and the second question from Pavel, and always about the trash in, trash out slide. How would you rate the 9 properties from most important, starting from the most important?
I'll try to rate them best I can. Part of the reason why this can depend is if you're dealing with something like source queries and you want to find out about do not translates, it's far more important to have proper nouns because that's the marker of do not translates. So having said that, how would I rate them? I would say that the top one is long word count. Like this is particularly problematic. I would say this is number 1, right? Noun count, number 2. Flesh reading ease, the readability, again, depending on the content, number 3. It's possible that in addition to this, you can also look at noun density, especially if you're dealing with like German or Slavic languages. I think this particularly is a big problem, right? Like if you wanted to do like nothing else but teach people to write in a more succinct way, you could just slap them on the wrist and tell them their word count is too much. If you really wanted to get more into the weeds and say, hey, it's not only word count because, don't give me short nouns because 5 short nouns is still a problem in a row, then you get into other features.
Okay. And one last question from Anna. Do you have guidelines for academic or educational content as a type and possibly at different age and grade levels?
For grade levels, yes, by virtue of the reading score. By type, it's still something that we're working out, to be honest. And it's a matter of having enough data to get to be able to say here's the average and the standard deviations. So I just want to reiterate, like what I want to present here is just kind of a methodology that I hope is useful to just everyone in the industry of how to think about this, right? I want to be descriptive. I don't want to be prescriptive and say it always fails this way because that's wrong. I hope that like the idea is that this methodology is flexible and capacious enough that it could fit different types.
Okay, thank you so much, Alex. It was a very interesting presentation. We had a great discussion, lots of questions. And another big thank you to all the participants for joining us. When I close the webinar in a minute, you'll see a post-event survey. I hope you'll take 1 minute. It's literally 1 minute of your time. If you could fill it in and give us your feedback, because that helps us refine our webinar program. Now, one small bit of news. There are 3 days left to submit a proposal for the Gala Fall Conference. So if you're interested, please go to our website, take a look at the suggestions, and if you feel so inclined, please submit a proposal. And yes, you can submit more than one proposal, because that was a question some time ago. So thank you again, Alex. Thank you, everybody. And oh, by the way, next week's webinar will be on localization and growth at Shopify. So I hope you'll join us then. And in the meantime, have a good day, have a good evening. Hope to talk to you soon. Bye.
Thank you, everyone.
Bye-bye.
Bye-bye.